Okay. So welcome to this second session of today's class, and here, as I promised I'm going to discuss how we get this, what is the interpretation of this function, how we get this particular curves, what is the process by which a statistical software can deal with the p-value, and if we do not have a statistical software and statistical charts are not reliable in this respect. So is there any way out for finding the p-value for chi-square distribution if we have the minimum requirement of having a desktop and laptop with us? So I'm going to discuss these points one by one. I hope my screen is visible to all of you. This is the domain of the statistical. It's not, this particular software is not a statistical software. This particular software is actually called, it's a mathematical software which can actually perform different types of operations. Like it can do calculations related to finance. It can do calculations, engineering calculations like control design. It can do curve fitting. It can do linear algebraic calculation. Optimization techniques can be done. Natural science calculations can be done. Various other different things can be done by this particular software, and also it can calculate the statistics and probability. Okay, so let me first of all open a new worksheet. So this is my new worksheet, and in this new worksheet I'm going to write a command which is like this, with statistics. And if I write this command, all these operations will be activated. So now we are able to perform. If I do not write this command, we will not be able to do the statistical calculations. Now my first question is that what is this curve that I was pasting over there? What is the meaning of this function? So let me discuss this point first of all. Let me go to the Maple help section. And in Maple help section, I'm going to write chi square distribution. This part, many hits are being shown. So I'm going to use this one, math apps chi square test. Yeah. Now this is this has been no, I have clicked on something else. Sorry, it's math apps chi square test. I don't want this. Sorry, just a minute. I want this one, math app chi square distribution. Yeah, so this is the thing. Now in this particular page, as you can see that the definition of chi-square distribution that I have just discussed, it is being it has been written. And you know that chi-square distribution is a kind of continuous probability distribution. What happened? Just a minute. Okay, so chi-square distribution is a kind of probability distribution which must have a PDF, and this is the PDF of the chi-square distribution. So what is written? The probability density function of the chi-square distribution is given by this form. So the form is x to the power nu by 2 minus 1 e to the power minus x by 2 divided by 2 to the power nu by 2 gamma function nu by 2, where the parameter nu is the number of degrees of freedom and gamma denotes the gamma function. So this is the probability function of the chi-square distribution. Chi-square distribution is a continuous probability distribution, and therefore this is the PDF. How can we get this curve? We have to plot this function for different range of the parameter, the input variable x, and thus sample size n. Here nu is the sample size, or you can consider this to be the degree of freedom. So you see, for when the sample size is only 1, if I put 1 over here, and if we consider this range of x from 0 to 10, we get this particular curve. As you can see, this blue curve will come when, with respect to this function, when I put the things, when I take the limit of x from 0 to 10 and the sample size is 1. When the sample size is 2, I'm going to get the yellow curve. When the sample size is 3, I'm going to get this red curve. And when the sample size is 4, I'm going to get this green curve, and so on and so on. So let me first check whether I can reproduce this particular curve with the maple or not. So let us try to find out whether I can, whether indeed I can have this curve or not. So what I can do, first of all, I can define the function in the following manner. So I'm naming the function as x, and let me define this function in the following manner. So okay, so first of all, we have x to the power, I'm considering this to be k by 2, or let us consider the sample size 3 or 1. Okay, I'm considering the sample size 1, minus 1, and I'm clicking on star. If I click on star, it gives you the multiplication sign dot. Then you can use the command exp, which is exponent, and then inside it you can write x by 2. Okay, so this is the function, and below we can write 2 to the power 1 by 2, because my sample size I am considering is half. And now I have to consider the gamma function. Now I do not know what is the command of gamma function, how to write the gamma function over here. So I am going to take the maple help once again. So let us write gamma function, and you see that gamma function is being shown over here. Somewhere is we have to search for the command of gamma, how to write the gamma function. Just a minute. Yeah. So this is my gamma. I'm going to copy it, and here I'm going to paste it. No, it is not being pasted. Yeah, and this dot sign must be there. I don't know whether it will. Sorry, this dot will not be here, but this dot will be here, gamma, and inside gamma we'll be putting half once again, nu by 2. Now this is my function that I've written. Gamma half is pi, root pi, is, you know very well. After this, we are going to use this command with plots. If I use this command, then we can, this plotting of figures will be activated. Now we shall write plot x, comma, x will run from 0 up to 10. And see, this curve is coming. The curve that is being shown, it is coming over here with respect to the function. Now, if what will happen if I change this 1 to 3, will the curve change? Let us try to find out. I'm changing my degree of freedom. All these things should be activated once again. And see, the curve is coming. So the thing that are being shown, in the definition of chi-square distribution, the thing that we are being, why it isn't, just a minute, the page is not coming, why? The chi-square distribution that was coming, so somehow it became, just a minute, okay? I'm resharing the thing with you. Yeah, so this is the point. So just like they showed you that for different sample size or for different degrees of freedom, different probability curves are obtained. So I am also able to find this particular curve with by printing this particular function, by giving the input of the input variables. Now, one of the important thing that I need to show you regarding the chi-square distribution is that, you see, I'm going to move this cursor a little bit, and we are going to check how for different degrees of freedom the shape of the curve is being changed. So if I take this cursor, and if I click on, if I drag this cursor from this to this end, what you are seeing is that the shape of the curve is being changed, and up to this 41 sample size, the shape of the curve is being changed like this, from this to this. So this is how the chi-square curve will change if I keep on changing the degrees of freedom. But what is important, and for different, they have written the program in such a manner for different mu x and for different variants that this is happening. So for when the degree of freedom is 1, the mu x is 1, sigma square is 2. When we are changing the mu to be, when we are changing the mu to be 2, then mu x and sigma square is also changing. For 3 it is also changing. For 5 it is also changing. But the important fact is that chi-square distribution is never symmetric. Chi-square distribution is never symmetric. It is not a normal distribution. Whereas T distribution was a kind of normal distribution, chi-square is not. If the normal distribution is there, then we know that the tails of the normal curve, they meet the x-axis as infinity. So x-axis, in other words, x-axis becomes asymptote to the normal curve. Okay, but chi-square starts from 0, and it goes like this. It goes like this. It goes like this. It goes like this, and so on. So chi-square is not a symmetric distribution, remember. So that is being shown by this particular point. Okay. Now the question, one question has been answered, that how did I got this? What is the meaning of this curve? Let me come to the next part of the question. My question was, what is the p-value? Now, how does the statistical software calculate the p-value, and why can't we? Now, what is p-value? Whenever I write the, let us consider the chart, statistical chart once again. The statistical chart that I was presenting, where is it? Just a minute. This is the statistical chart that I was presenting, isn't it? So now you see that in statistical chart, whenever I write this, what does it mean? It means that, suppose I'm talking about this point, say for example, I'm talking about this point. So whenever I write that chi-square is for 3 degrees of freedom at 0.5% level of 0.05 or 5% level of significance is 7.81, it means that probability that chi-square will exceed 7.81 is having the probability 0.05. That means what? That means you have some function of chi-square, some probability distribution of some PMF of chi-square, which I denote by chi-square PMF. and you are going to integrate this from 7.81 to infinity dx, or some other variable integrant you can use. This probability is coming out as 0.05. This integration, and you know the function of the chi square PMF, as I have just shown you, it is a little bit of complicated function. It is x to the power n by 2 minus 1 into e to the power minus x by 2 by 2 to the power n by 2 into gamma function of n by 2, isn't it? So in other words, you are going to integrate this particular function. You are going to integrate this particular function from 7.81 to infinity, and then you are going to get the probability. Now this function cannot be, this integration cannot be done analytically. For this, you need to take the help of numerical integration. There are various numerical integration process, like we have, you have to know the names and you can later search. We have trapezoidal rule, we have Simpson's 1/3 rule, we have Wedel's rule. All these rules are there for calculating. Simpson's 3/8 rule is there also. So with the help of each of these programming, if you can get hold of these algorithms, you can write the codes in the C and you can check whether you can calculate these probabilities or not. Okay, codes are available. So you have to have you are learning C, isn't it? You are learning C language in this semester. So what you can do, you can get the code blocks and where you can put the C commands. Okay, of suppose you have got the access of the C language code for Wedel's rule. So you take the help of that code and paste it in your code blocks portal and try to integrate this function. Okay, you will, maybe it may so happen that you have, if you have properly done, if you properly do it, you are going to get all the probabilities that is being shown over here. So all the statistical calculations, all the statistical probabilities that are being shown in the table are the outcome of the numerical integration done on the probability function. Now this probability function, statistical software, what they do, they have written the algorithm for this particular thing. They have written the algorithm for calculating various probabilities, and whenever I am typing in this command, a simple command, it looks very simple, isn't it? I'm talking about this command, this chi square independent test x level 0.05. Whenever I'm typing this command, inside it, behind the screen, various other complicated mathematical programming is being played. It is calculating the integration. I do not know how they have written the code because I am not a computer expert. But suppose you are actually developing a software for chi square independent. I have asked you to develop a chi square independent test. So it may be a kind of project for you that, yeah, let me see that whether I can develop a statistical program, a programming for a kind of statistical testing process. Okay, so behind this particular simple command, there is a huge programming in which they have calculated different probabilities by considering the probability density function of the chi square test. And not only this, they are also, all these probabilities are what? Their level of significances. They have also optimized the thing behind this command, and they can identify the minimum level of significance at which the null hypothesis would be rejected. The minimum probability, they are also hitting at this point. So command looks very simple, but it is too complicated. Okay, so that's how, therefore, it is not written in any book. I have dedicated one entire day to get yesterday also I was doing my part of research, and I was thinking that how does this softwares do the statistical calculation. During the process, I got hold of several other things that are being reflected in your WhatsApp group. I sent you various things in the WhatsApp group last night. This is my whole day's study that I have jotted down and I posted in the WhatsApp group so that you can read. They are also very interesting. Now, that's why the statistical software is so precise. They can calculate the p-value. Statistical table do not have the provision for taking all the p-values at a time. So this is the added advantage of using a software. Now, my third question was, a person who is having a statistical chart only, who is not having any statistical software with him or her, and who has a desktop at least with him or a laptop with him, then what he can do, he can take the help of Microsoft Excel. So as you can see, that is also my part of research, and several tables that you can see over here I have written. And I'm going to talk about this also. Why have I written several tables, several data over there? One of the data that I must bring your attention to is the following data. My problem that I started with, this was my problem. And I wanted to see whether I can calculate the chi-squared value with the help of Microsoft Excel or not. So that's why I told you that this is the minimum requirement, that you must have a desktop. At least you can have that. You can take the help of the statistical. You can take the help of the Microsoft Excel to help you out in this regard. And I found that the answer is yes. But there is a punchline. I'm coming to that punchline later on. How to find this? You have to click a blank cell like this. Double click over here. Put an equality sign. Now you can select the thing from formulas also, or you can type in over there. There are two ways. Let me show both the ways to you. From statistical, you are going to select this thing, chi-square test. Okay, so this will open. First of all, you see that what I am doing. This has opened, and in the actual range, we are going to put the range of the observed frequency. So from here to here. In the expected range, I am going to put the observed frequency from here to here. And I'm getting certain value. See, so click on this. So it is your value 0.00214405. Or you can do one thing. You can directly type in the chi-square test. Chi test, and then you can select this and put a comma, and then you can select this and put a and complete your bracket, then also 0.00. This value is being obtained. Now, what is this value? If I carefully observe this value, I have looked for it in various parts of this particular thing. I have looked for it, but I didn't find the answer. My answer was not available. Now, see, what is the problem with this? The chi-square test that I used over here, if I take the help of this particular, what is my, if I use this particular command, this is actually calculating the value, one sort of value here, but this value is not at all my value of the chi-square test. If I carefully observe, I will see that this value that the Excel is calculating is actually the value of actually the p-value 0.0020000214. See, just look at, just compare the two values, 0.0002144. It is not calculating. This is the problem with the Excel, is that it is not calculating the chi-square. Yeah, help. Oh, yeah, help on this function. If I click on this help of this function section, what we are finding is that they have written the syntax of the chi-square test. Here they are saying that if you use this command, equal to chi test a2 b4, like this, just now we have used this command. If I use this command, then this calculation with respect to their data, this calculated value will come, and it will also be calculating the degree of it will also be calculating the p-value, but it is not doing this thing. The answer to the question is not known to me. I have not found. I have seen several videos in YouTube, but one such video, the person who was actually discussing the application of Excel in with respect to chi-square test, she also got puzzled. Somehow the software is not calculating your chi-square test value, but it is calculating correctly the p-value. So the punchline is that sorry, just a minute. The punchline is that though the person who has at least the desktop with him or laptop with him, he can do, he can take the help of his manual calculation. He can take the help of his manual calculation and the help of Excel together. From manual calculation, he is going to get the chi-square test statistic value, calculated value of chi-square test, and he has the statistical chart with him, so he can compare the result at different levels of significance. But if he is unable to find the p-value by the statistical chart, or by he doesn't have any mathematical software, then he can take the help of the Excel, and he can, from the calculation of Excel, from this command, he can at least get the p-value. He also will be able to get the p-value if he is not having any mathematical software with him. He can combine his manual calculation with his Excel knowledge, and then he can get the result. So, but the person who is only using his mobile phone for attending class, doing things, he is in a kind of position where he will not be able to apply any of these things. He has to rely on the statistical chart only. Now, this is the problem. This is the problem with those students who are not having any of these facilities because of the current scenario. He is in remote area where network connection is poor. But I also very much concerned about those students. I know that I can lecture many things in the online platform, but from your end, sometimes it is also it's a big trouble. Okay, so internet connection problem is there. Not you are not accessing any desktop or laptop, or you are in a remote village, so you may think that sir is giving lectures on these statistics, but I do not have this facility. How can I do? So in that case, you have to rely on your manual calculation ability. That at least that much I can say. So yeah, somehow Excel calculated p-value, and we got combining this with my manual calculation, we can at least say that yeah, chi-square test is accepting or rejecting the null hypothesis, and this is the p-value, the lowest level of significance at which the null hypothesis should be rejected. or the lowest level of significance, or the probability of committing the type 1 error, whatever you say it. Okay. So the best part is that if you have facilities, then I will say, as in one of my classes earlier, told you that, yeah, the easiest available software is Excel. So we can do the statistical calculation with Excel, but Excel has certain problems. Nobody has thought of ever modifying the Excel with respect to the statistical calculation. Nobody is modifying because various other statistical software are coming into the market. Nowadays, Python is in vogue. Some people use R statistical software. And I'm pretty much sure that if anybody is using MATLAB or Mathematica, they will also be able to perform the statistical calculation. Or there is a software which I came to know about a few years ago, developed by IIT Bombay. It's called Scilab. Then if anybody is using Scilab, he will be able to do the statistical calculation. Or there is a software called Minitab. There is a software called SPSS. So various softwares are there. So let me write the names of the softwares: SPSS, R, Minitab, and Scilab, MATLAB, Mathematica, Maple, and lastly Excel. And there are others also, but I do not know their names. Now, best part is that try to get hold of any of this software. Try to get any of this software and try to learn how to, one another software is there for doing, for writing Python. I do not know the name of the software, but I forgot the name of the software. So the programming name is Python, but the software name is not Python. The portal has a different name. Okay, I try to get it from Google. I forgot. So try to get a hold of any of these and try make yourself comfortable with the software and try to do this part of calculation you want to do. I personally have Maple with me. I got it during my research days. I recently downloaded Mathematica, but I am not able to use it because I am learning it. R, I have downloaded and it is easily accessible from the internet. If you want, I can give you the link of the site from which it can be downloaded. But do not ask me the link for this particular two softwares. Of the record, I do not. I will later tell you. I'm not going to say anything right now in this because the video is being recorded. And this is the easily available software. So you can take you try to download any of these softwares, and if you are downloading R software because it is easily available, then there is also a very good book on R, which will help you to, which will guide you to do the calculations in R. I am also learning it. I cannot use it. So since I have access of this software and see, I know a little bit of Maple. I know a little bit of Maple. I'm familiar with this. So that's why I have shown the calculation in Maple. I do not know what are the limitations in Maple. What sort of statistical calculations that cannot be done in Maple. I do not have this idea. But since I have got the idea of how to do the calculation using, how to do the chi-square statistic using Maple, that I have presented to you. Now it is up to you. And with this, I'm going to conclude my discussion on chi-square test. I do not think that any more discussion is needed on chi-square. Maximum discussion has been done on this. Okay. So today I have a class with CSC section B. I have not yet decided what I'm going to talk about in their class. I have to study now, and tomorrow will be again meeting in our scheduled time at 1:40. So till then, bye. Hope you have enjoyed. Hope you have understood.
महंगा नहीं है।